Hi ladies, it's Mr. O'Sullivan. Today we're going to be looking at Lesson 3-6, Introduction of Parallel Lines. Our learning target for today is, I will apply the properties of parallel lines to determine the value of a missing angle or the value of a variable. So what we're going to do first is we're going to identify the angles being described by their relationship. So we have interior angles. Whenever you think of interior, think of like the inside of your parallel lines. So if I look, these two lines are parallel to each other. So my interior angles are angle 3, angle 4, angle 5, and angle 6. Those are the angles that are on the inside of my parallel lines. And they have no relationship. They're not congruent to each other, they're not all adding up to 180 or any of that stuff. So by process of elimination, your exterior angles are the angles on the outside. So in this case, the angles on the outside of my parallel lines are 1 and 2, and 7 and 8. Now we have our alternate interior angles. So those are angles between our two parallel lines on the inside and alternate each other. So I can say angle 3 is alternate interior to angle 6, and they are congruent to each other. And then I can say angle 4 congruent to angle 5, and those are my alternate interior angle pairs. Now alternate exterior angles are angles on the outside and alternate to each other. So I can say angle 1 and angle 8 are congruent to each other. And then I can say angle 2 and angle 7 are congruent to each other. Corresponding angles. So basically what that means is these are going to be congruent as well, and it's a literal slide down. So I can say angle 1 is congruent to angle 5. I can say that angle 3 is congruent to angle 7. I can say angle 2 is congruent to angle 6. And then I can say angle 4 is congruent to angle 8. And those are your corresponding angles. Now your same side interior angles are your angles on the same side of your interior. So if I look, the angles on the same side of this interior are angle 3 and angle 5, and they add up to 180. And I could say angle 4 and angle 6 are also my same side, and they add up to 180. So when two parallel lines are cut by a transversal, my alternate interior angles are congruent. So we're going to set them equal to each other. My alternate exterior angles are also congruent, and we're going to set them equal to each other. My corresponding angles are also congruent, and we're going to set those equal to each other as well. And then last but not least, our same side interior angles are supplementary. So add together, and then set equal to 180. And that's how you're going to approach those problems. Okay. In the diagram below, AB is parallel to CD, and EF is a transversal. If I look, it says the measure of angle 1 is 8x, and the measure of angle 2 is 6x minus 30. If we look, angle 1 and angle 2 are same side interior angles. So we know same side interior angles are going to be supplementary and add up to 180. So I'm going to do 8x plus 6x minus 30 equals 180. I combine my like terms. 8x plus 6x is 14x. Minus 30 equals 180. I get rid of my minus 30 by adding 30 to both sides of my equation. So I get 14x equals 210. And then I divide both sides of my equation by 14. When I do this, I get x is equal to, let's see, 15. X is equal to 15. And that's your final answer, because it just says find the value of x. Number 2, determine the value of angle MPQ. If I look, these two angles are corresponding. So we know corresponding angles from above we set equal to each other. So I'm going to do 5x equals 3x plus 50. To get rid of my 3x, I'm going to subtract 3x from both sides of my equation. So 5x minus 3x is 2x. So I have 2x equals 50. And then to get rid of my 2, I divide by 2 on both sides of my equation. So I get x is equal to 25. But here's the issue. The question's asking for the value of MPQ. So everywhere I see an x, I'm going to substitute a 25. So we know angle MPQ is 3x plus 50. So I'm going to substitute 25 in for x. So 3 times 25 plus 50. Well, 3 times 25 is 75. 75 plus 50 is 125. So I can say that this angle is 125 degrees. And that's my final answer. Number 3, determine the value of x. If I look, these two angles are alternate exterior angles. So alternate exterior angles, I simply just set equal to each other. So I'm going to do 12x plus 17 equals -1 plus 14x. I want to get x's on one side, so I'm going to subtract 12x from both sides of my equation. So I get 17 equals -1 plus 2x. Add 1 to both sides of my equation. I get 2x is equal to 18. And then I divide by 2 on both sides of my equation to get x is equal to 9. And that's my final answer. Number 4, find the value of x and y. If I look, I'm going to deal with my x's first, so I have to figure out their relationship. So if I look, I can do an alternate interior angle and say I have a 3x right here. And then I know that angles on the same line are going to add up to 180. So I can do 9x plus 12 plus 3x equals 180. Combine your like terms of 9x and 3x, and you get 12x plus 12 equals 180. We then subtract by 12 on both sides of our equation. 12x is equal to 168. So 168 divided by 12 is 14. So I get x is equal to 14. Now I want to solve for y. If you think about it, 4y minus 10 and 9x plus 12 are exterior angles that are alternate. So they are congruent to each other. So I can do 9x plus 12 equals 4y minus 10. But the thing is, I know x is 14, so I can substitute that 14 in for x. So 9 times 14 is 126, plus 12 is 138. So I have 4y minus 10 equals 138. Get rid of my minus 10 by adding 10. So I get 4y equals 148. Divide by 4, divide by 4, and I get y is equal to 37. And that's my final answer. And that's how you deal with parallel lines cut by a transversal. If you have any questions, email myself or Ms. Colarundo.